Hello, everyone. Today we're going to talk about volcanoes. Some people think of them as windows into the earth. I just want to talk about some important vocab and then we'll discuss different types of volcanoes and whatnot. So, first of all, a volcano is a mountain that's formed by lava and pyroclastics, which we'll define later, but just fragments. Um, Generally, if a volcano has a crater, it is an opening at the top of a volcano, and it may vary in size. But if it has a caldera, it's usually a summit depression, like the one in this picture right here, that is larger than 1 kilometer in diameter, and it's usually caused by the magma chamber actually collapsing. And that's what happened here. Once the material was ejected out, the magma chamber collapsed. And this is Mount St. Helens. Other vocabulary that we need to understand is the difference between an active and a dormant and an extinct volcano. An active volcano is one that's erupted within recent history, so usually within the past 100 years, and has the potential for erupting again. A dormant volcano, just like a dormant animal, has no recent eruptions. Nothing's really happened within the last several hundred years, but the mountain hasn't eroded or anything. So some say it might be active again. And an extinct volcano, just like an extinct animal, is no longer erupting. It hasn't erupted in the past 1,000 years. It's eroded away and it is not gonna erupt again. Where do we find our volcanoes? Well, we looked at a map earlier when we talked about earthquakes and plate tectonics, and you can see where a lot of them are here. About 1,900 volcanoes in the world are active or known to have been active during recent times, and 90% of those are around the Pacific Plate, so somewhere on the Ring of Fire, otherwise known as a band of volcanoes circling the Pacific Plate. We know that there are volcanoes at divergent plate boundaries. This is where two plates are moving apart at mid-ocean ridges or continental rifts. They also happen at subduction zones, where the ocean, which always involves an oceanic plate converging with another oceanic plate or a continental plate, and that's what's happening around the Ring of Fire. And then the final place is at hotspots. So that's a fixed source of magma in the center of a plate. Hawaii, the islands of Hawaii and Yellowstone are thought to be that. So here's a picture showing seafloor spreading, and often you get some volcanoes right along there. That's how Iceland's volcanoes have formed. And there's one showing a hotspot, which is a fixed source of magma, and as the plate moves past it, new islands are formed. So Kauai is the oldest island, and right now the main island of Hawaii is on top of that hotspot. And there's just showing a subduction zone. What happens is the friction right here creates heat, melts some of the mantle material, and then eventually it erupts. So here's a practice question for you. What's the difference between a crater and a caldera? Really, it's all about size. Is that picture below a crater or a caldera? It's a caldera. It's hard for you to tell the scale, but it is quite big. Another question, what's the difference between a dormant and an extinct volcano? Well, that would be the time since the last eruption, as well as the amount of erosion. And where do most volcanoes happen? Come on, Ring of Fire. Also at convergent and divergent boundaries, not transform. There's various types of eruptions. There's the non-explosive eruptions, and those have really thin lava that's not very viscous or thick. Hawaii has classic non-explosive eruptions, as does the magma coming out of mid-ocean ridges. And then the other type is explosive eruptions, and they tend to have thick, viscous lava with a lot of gas to create explosions. And they tend to give off a lot of pyroclastics or fire fragments. Mount St. Helens and Krakatoa are two examples of explosive eruptions. And then finally, there's three main or four main types of volcanoes. There's shield volcanoes, and they we'll talk about were named because they look like a warrior shield. There's cinder cone volcanoes and composite or stratocone volcanoes. And then there's also fissure eruptions. Shield volcanoes tend to have mafic or basaltic lava, and they have like flowing quick streams of thin or low viscosity lava flowing easily from their gentle slopes. They tend to be pretty flat and low compared to their diameter. Each of their flows is only a few kilometers thick. Mauna Loa in Hawaii is a classic example of that. It's 2.5 miles above sea level, and it goes 6 miles to the ocean floor, but it's 60 miles at its base. So you can see it kind of bubbles out. It's not violent explosions. And there you can see the classic shield volcano. It's long and flat. Not flat, I mean, it's a mountain. And there's a picture I took while I was in Hawaii of one of those volcanoes in Hawaii. And notice how they're just sort of flat and wide, although they are 13,000 feet tall. So John and I were at the beach one day, and then we were up in the snow the next, and there were literally people skiing there. The next type of volcano that's kind of unusual is a cinder cone volcano. These are small, steep, cone-shaped volcanoes. They have a lot of gas in them, and they release little to no lava, but they do have rocks and stuff flung out of there. I think of them as sort of a dry volcano, but that's not necessarily what they are. They have a lot of pea-size material called cinders that pile up and form that distinct cone shape. And there's an example of one of those. They don't get very tall, but they are rather steep. Usually they're, less than a couple thousand feet tall. And the classic volcano that you see in pictures are composite or stratocone volcanoes. And these are built with alternating layers of lava, flowing lava, and fire fragments called pyroclastics. They tend to have thick, gas-charged lava, and their eruptions are pretty violent. So you can see here they have alternating layers of lava and then pyroclastics and mud and stuff like that. And over time, they build up layers and layers. And a lot of the volcanoes in the Cascades in Washington are stratocone volcanoes. This is a cool picture. This is Mount St. Helens before she erupted in 1980. And I'll show you one from after. And this is a picture of a volcano in Africa. Fissure eruptions I sort of think of them as like a weeping or oozing wound. They, when you have a crack in rock and there's some magma coming out, those are fissure eruptions. And they produce liquid flows, not a lot of pyroclastics are ejected. So just to understand what pyroclastics are fire fragments. And there are different sizes. The smallest fire fragment to come out of a volcano is ash, which is really fine. They sometimes refer to it as glassy fragments. Sometimes the ash fuses together and makes welded tuff, which is almost like, it's like the insulation material that you might see in people's house. But it's bigger than ash. Cinders are pea-sized pyroclastics. Lapilli is walnut-sized, so you can imagine getting hit on the head by that. Wouldn't feel so good. Lava blocks are just sort of variable-sized, large blocks of stuff coming out of a volcano. And lava bombs are these like football-shaped, incandescent lava blocks that are thrown out. And pumice is frothy material with air spaces, and some of you have probably seen pumice. They use it to wipe calluses off of things, but they have air bubbles in them and whatnot. So there's pumice. The difference between magma and lava is pretty easy. Both are molten liquid rock with a bunch of minerals in them, but magma is underground in the interior of the earth, and lava is on the exterior of the Earth's surface. Whenever we talk about magma, we talk about their viscosity, and it's maple sugaring season, so you guys all know what viscosity is. It's like the thickness or how easily something flows. And viscosity can be affected by a number of different variables or factors. One is what kind of minerals are in there. Another is temperature, and the other is dissolved gas. So if you were to just rank the following from high to low viscosity, you had a thing of ketchup, vitamin water, magma, and maple syrup. Which one do you think would be the highest viscosity, meaning the thickest? Think about that for a second. So first, the thickest would be magma, then probably ketchup, then maple syrup, and then vitamin water. So silica is chalky substance. It's often white, that's found in rocks, and it's pretty common. It makes up about 95% of the Earth's crust. And a magma's viscosity is pretty directly related to the silica content. If there's a lot of chalky, thick, white material in there, high silica magmas like granite have really thick, short flows, whereas low silica magmas like basalt have more fluid lava that can travel almost 90 miles and have low viscosity. Obviously, higher temperatures decrease the viscosity, so you heat up maple syrup and it flows more easily than if it's cold syrup. So as lava cools, it begins to thicken and its movement decreases, so it has higher viscosity. And then finally, there's gas in volcanoes, and as magma reaches the surface, the pressure is reduced and the gas expands with explosive results. So the gas composition in a volcano is going to vary, but there's always some water, vapor, some carbon dioxide, and some sulfur, chlorine, or fluorine gases. But the more gas, the more explosive the eruption, but it also affects viscosity. High gas means lower viscosity, and I like to think of a Coke, like if you open a can of Coke and you pour it, it flows pretty fast, but if you have like a Coke that's been sitting in the can and it's been open, it's going to be thicker and higher viscosity. So deep below the surface of the Earth, the pressure is pretty high, and volcanic gases get dissolved in the liquid. And if the magma has low viscosity, the gas bubbles can easily escape. But if the magma has high viscosity, the gas bubbles get trapped and thick and gooey liquid, and the gas pressure builds up until an explosive eruption. So low viscosity magmas that allow gas to escape produce non-explosive eruptions, but high viscosity magmas that trap the gas tend to produce explosive eruptions. And you can think of a soda bottle analogy. Dissolved gas is under pressure inside of a bottle. It escapes violently as the pressure drops. So 3 things that might affect the viscosity of lava. You got it. Silica, heat, gas content. And how do each of them affect viscosity? Temperature causes viscosity to go down. High silica content causes viscosity to go up. And dissolved gases, if there's high gas, it's low viscosity. So what type of eruption would happen if the magma has a high silica content and high gas? Explosive. What type of eruption would happen if the magma had a low silica content and low gas? Non-explosive. Great. I think we'll stop there and we'll talk about lava flows in class. But thanks for listening, and I'll see you tomorrow.